Namaskar, I am Parth. Today, in this session, I will show you how to color a grayscale image, or if I say in different words, how to segment a grayscale image using K-means clustering algorithm. Here, we will segment the image, grayscale image, into a colored image based on K-means clustering. Suppose if you see this image, let me just show you the original image also. See, this is the original image. If you see here, there are some clusters, like there is a man, there is a camera and a background, right? So here by using this function, I am dividing it in two clusters, and you can see foreground and background is reflected here or clustered here. So we will learn this, how to do this. Okay, so first of all we will see a little bit of what is K-means clustering. It's a algorithm part, right? We will use this. Suppose we have some numbers in spatial arrangement, in spatial arrangement, like 4, 8, 2, 12, 19 and say 25. Okay, we have this 6 numbers. First of all, we learn in one dimension, right? So suppose we have to divide in 3 clusters, or let's say first of all 2 clusters. So what we will do, initially we will choose any 2 random clusters, like I will choose 19 and 25. Okay, let's say. Okay, so we will find distance from these 2 centers of all members. Okay, let me use Excel to write this. These are our members 4, 8. We will not change the order because in image their spatial arrangement is very much important. Okay, 4, 8, 2, 12, 19 and 25. Okay, we will find distances from 19 and 25 because that are current cluster centers, randomly selected cluster centers. Okay, I will quickly write this. Okay, now after getting distances, we will assign clusters. We will assign a cluster to numbers like 4. 4 is very near to our cluster center 19. So we will assign the cluster belongs to 19. The cluster which is centered at 19. Okay. Now 8 is also close to 19. So here once again 2 is also close to 19. 12. 12 is also close to 19. 19 is itself close to 19 and 25 is close to 25. So these are our current clusters, right? Now what we have to do, we have to decide a new cluster center from all available clusters. Like suppose we start with 25, then 25 is the only element in its cluster. So there will be no change. The new clusters will be, one will be 25, but we still need to find other cluster, like the 1, 2, 3, 4 and 5 elements are in the cluster centered at 90. So now how we will find new cluster like this? Values are 4, 8, 2, 12 and 19 divided by 5. So here we have 9. So our new cluster center will be 9 and 25. Now again we will repeat this process. We will write distances 5, 1, and yes, we have to write the mode of distances. If it is a negative distance, we don't care because it's distance, right? Okay, 7, 3, it should be same, right? as previous, because it's the same center. Okay. Now once again we will assign clusters. Let's see if there is a change in cluster or not. Okay. Now here it is a 9, right? Once again 9, 9, 9. But here 21st cluster is more near to 19, right? So this will be 25 and this will be 25. Okay. So now what will happen? The new two clusters will be one from this fourth, like 4, 8, 2 and 12. Sorry, 12 divided by 4. So 6.5. So we will write it 7. We can also use 6.5, but it's fine. We'll use 7. And the other cluster will be average of 19 and 25, which will be 22, I guess, right? So these are our new clusters. We will repeat this process again and again until the clusters are same. Here, see, this 19 was in its own cluster 19, but when the new cluster center became 9, the 19 went to the cluster 25. So it changed. At a point where in two consecutive instances this doesn't change, any element doesn't change its clusters, it means we have clustered the image very well. Okay, so that's a very easy thing, I guess. It's just a repetitive process. That's why you use Matlab. Okay, so let's start implementation part. Now, here is the interesting part. We have learned this algorithm in one dimension, right? But the image is in two dimension. See, this is the image. It is 256 cos 256. This is a 2D image. If it's a color image, it can be 3D image. But here we are talking for grayscale images. So it will always be a 2D image. Now we can do like we can reinvert our algorithm from one dimension to two dimension. But here is the tricky part. What we will do, we will convert this 2D image in one dimension array like this. B is equals to A of channel, right? So you can see like it became 256 into 256 cross 1, right? So now it's a linear array, one dimension array, as I recently showed you in the paint, right? So now we'll apply our algorithm here, and let me show you how and what things are we gonna do. Okay, so let's start the implementation part. Here I have already created a function because it's a very lengthy code and hard to explain. So I will try my best, and this code will also be available for you without any cost. Feel free to ask for the code in comment section, or you can mail to us also. Even if you have any queries regarding any other image processing problems or computer vision, even in machine learning, you can mail us. We will solve your problem without any cost. We are happy to help. Okay, so let's start this. Here I have named it K clustering, which will take input a image and the number of clusters in which you have to divide image. Now it's actually a drawback of K-means clustering algorithm that it doesn't tells you that how many clusters should be there. Like you have to do trial and error for the best results. In any given data, even if it's for a machine learning purpose, K-means algorithm, you have to play with number of clusters. Like if you have any insights about data, like by seeing you know that there might be 3 clusters, then you can try that. But you have to play along with a number of clusters. That's a drawback for K-means clustering. Okay, so we'll give input an image and number of clusters. And this here I am just saving in the image in its original shape, because in the next step I am converting it into linear, as I recently showed you. Here you see this B. This I am doing with A, and this letter sign uh, converts it into 1 cross 65563, like this. If I do this, see, it is now 1 cross 65536, right? And here you can see here it is in U integer 8 format. So like some operations like multiplication or summation points are not possible with U integer 8 or unsigned integer 8 format. So we are converting it into double. Okay. Now there is a new command for you to learn. Some of you might already know. It's random permutation. So here we have to, the idea is to select initial cluster centers as randomly. Let me just show you how this works. If I write random 5 into, so it means it will give me two random values from 1, 2, 3, 4 and 5. See, right? If I write 10 here, so it will give me from 10. Okay. Now, if there is an array like this 6, 4, 7, 10, 12, 13, 20 and 100. Okay, we have array. There are 3, 6 and 8 values, right? 8 values in it. Now if I want to select randomly 2 values from these 8, then what I will do, I'll write A of random permutation. So total 8 values, I want 2 from that, right? There we have. So this is how we do it. Now in this image, I will use this numeral command to know there are how many total number of points, like this 6, 5, 5, 3, 6. So total number of pixels is I am getting this by numeral. So I'll write this size and k, which we have given in input, right? So here we have initial clusters, initial cluster centers. Okay. Now I am creating a blank cluster center array to store new centers after the first iteration, right? Whenever we complete one iteration, every time we will have new cluster centers, and we also have to compare old and new cluster centers to check if we have clustered well. If it's not changing, then it means we have to break the loop. So here this is my loop command. See, so while this is 1, this loop will run. Once it is 0, then we have finally clustered all the things, right? Okay, so let's start this while loop. Okay, this is the distance which we just calculated in Excel, right? A minus C of gem. So it will give me clusters for all. Let me just go by this so I can help you understanding. So we are running this code for 2 clusters with that image, right? Let me just read that image, camera mount. This one, right? And I will run this. Okay, so here we are. Let me run this section. Now see, the 2 clusters we decided randomly were 166 and 9 using this statement, right? Now we are finding difference from all of that with our cluster centers, which is stored in D. You can see this is how it looks, right? The code snippet is like A minus C of gem. Now this is like a crucial part here, because it might not work in some versions of Matlab. So you have to be innovative here. If your version doesn't helps you this, then you have to do something on your own. The thing is to find the difference, and the output should be in this format, right? Okay. Now the same process which we are doing in Excel, Like we'll assign the cluster centers which have minimum distance from a member and cluster. So that's what I'm doing. I'm finding the minimum distance of all of them, and I will get the index in this. It is the first or second. In L I will get 1 or 2. If I get 1, I will assign there 1. Otherwise I will assign 2. Right? That's it. Now this variable, let me just reach there. How this variable looks, a final. Right? See, there were two clusters, right? 166 and 9. So these are all the values of our image, and in the second column, it is centers assigned to that member. Like 156 belongs to the cluster with center 166, right? See, you can also see that some are assigned to 9. Whoever are near to 9 are assigned to 9. Whoever are near to 16 are assigned to 166 are assigned to 166. Right? Okay. Now we will move forward. Now what we will do? We will find the new clusters. Right? This for loop finds new clusters. New cluster centers, precisely new cluster centers. So what we will do, we will take mean of all available members in that cluster, and then we will floor that value. Suppose it became 6.7, then we will use 7. We even can use the ceiling value, but that will not make any difference, right? So by the end of this for loop, we will have new clusters in C2 variable. Let me just remove from here, so we'll be directly here. Okay, see, the previous selected were 124 and 145. It changed because I rerun the program, and as you already know, it is randomized. But you see, the new selected clusters are 61 and 165. It is different from the previous values, right? So here next we are comparing it. See, we are finding the break value, and if it is equal to k, means if we are dividing in two clusters and both clusters are same, it means you have to stop. Now the clustering is being done. If it is not, then what we will do, we will the newly found clusters will be given to variable c, and c2 will be cleared. So in the next iteration, c2 will be regenerated, right, from here. Okay, and this n is just to find the how many loops it taken to reach the end value, right? Now what will happen, see, by the end of this, we get a variable a final. Let me show you. So these are the final clusters. Like member 156 is assigned to 153, and the other center is 23. Yes. So finally, after 6 iterations, see here n is 6. So after 6 iterations, we found that these are the two cluster centers, 23 and 153, and all the members are divided between these two clusters. Now what we'll do, we'll label them. Like wherever there is 156, we will place 1 in the image, and wherever there is this 23 assigned cluster, we will place 2. So this is how we will label. We will start from 1. We will search for any clusters, right? So first we will do for 23. C of 1 will be 23. So any value in this second column will be 23. Then at that locations 1 will be placed, right? So after this end of labeling, let me just show you what will be the output of that matrix. It is IM, right? See, these are all the pixels. See, this pixel is in cluster 2. It is labeled as 2, right? And there will be some pixels which will be clustered in 1. See, these are the pixels in cluster 1. So here we have labeled based on the cluster number, like 1 and 2, right? Now there is a command in Matlab, label to RGB, which gives colors based on the label. Like if there are two labels, 1 and 2, it will give separate colors to those points, and we'll have the result, you see, right? Let me show you with different cluster centers. We'll try for 3. See, now in two cluster centers, let me just show you once again 2. The only thing separated was the cameraman and background. But if we go for 3, then see, 3 things are clustered, like the sky, the ground, and the cameraman. Okay, if I go for 4, then the result will be still different. Now you see, 1, 2, this 3, and the fourth one is the like objects in between sky and ground, which are buildings here. Let me show you original image. There were some buildings. See, so now the 4 clusters are: one is the sky, second is cameraman, third is ground, and the fourth one was this buildings. So there were the 4 clusters. Let me show you once again one very important like advantage of this type of clustering is, I'll show you image of my friend Pavin. I have taken it while cycling, and there is a lot of motion blur, and it's not linear motion. If you see, it is like a circular motion blur here. Once again here circular motion due to this paddling, and in different directions there is motion blur. So it is very hard to eliminate this motion blur. But if we do clustering on this image, let's see what the results we get. First we will convert it into grayscale image, because what we have created will only work in grayscale image, right? So here we have 4608 cross 3456. That is very big image. It will take a lot of processing times. So let me just resize it. We'll use it only 10%. Let me also show you this image, grayscale image. So this is that image. You can see face is not clearly visible. It's like messy image. Now let's cluster it. We'll start by 2 clusters. I'm sorry. A is very big image. We have to write key. Okay. By doing 2-point clusterization, or by assigning 2 clusters, this is the results. The results are not so good, but I'll show you good results. We'll try for 4 clusters. And there are a lot of color space in this label to RGB image. This clustering is good, but due to this red and yellow color, you are not liking it. I'll just again run the same code. There will be a different, slightly different, and you see now the color code just change a little bit. It looks good, and with 5 cluster centers, it is really good. I have tested it before. See, let me show you. Previously I have done it. There you see. This looks better. This looks way better than this one. You can compare yourself. This is way better than the left one, right? So there this kind of clustering may be useful. It may also be useful in like health in diagnosis from MRI or X-ray images. It may be useful, but again here we have done is not two-dimensional clustering. It is only one-dimensional clustering. We are just playing with dimensions. We have converted two-dimensional image in one dimension. Then we clustered, then we labeled them, and we can again convert it into its original size, right? But there also exists a two-dimensional clustering, which would even be better. But these results are like just good to see. It's like filters we get in different smartphones or in Photoshop. It's like filtering an image, right? In Instagram we filter image. It's same like a filtering, right? See. Thank you for watching the video. Please like, share and subscribe the channel. Thank you.